Optimize! Sick Mr. Patey here, giving you guys an instructional video on optimization. Now you'll notice that this problem doesn't say optimization, it just says find a point that's closest to the origin. So to give us a better understanding of what's going on here, I drew a little picture for you guys. This F kind of looks like this. And what we're trying to do is trying to find one of these points, which one is the closest. Now if we're trying to find a point that's the closest, we need the distance formula. We get the distance formula from the Pythagorean theorem, okay, as you can see right here. I want to explain the distance formula really fast because it's important that you guys remember this formula. And so I'm going to pick 2 points right here and show you guys how we find the distance between those 2 points. Now, if you pick any 2 points on a graph, you can draw a right triangle from it, with it. And so you can see right here why we can use the Pythagorean theorem to find that distance between the 2 points. But the thing about the distance formula is we can't use the x and a y like that. We have to use points. You have to use coordinates. And so I labeled all my points right here. We have our x1, y1, our x2, y2. And this point right here actually uses the same x and y's from the other 2 points. Now what we're going to have to do to find the x is we're going to have to subtract these x's so we can find the distance, the length of this x right here. And that's a really simple concept in math. If you want to find the distance between 2 numbers, you just have to subtract them. And so instead of writing x, I write x2 minus x1. And then instead of writing y, I write y2 minus y1. And there you have it. There's our distance formula. Our distance equals the square root of that stuff. Now the problem with this is that we have y's and x's inside this distance formula. But we want to have a distance written in terms of x or written in terms of y. That means only x's or only y's. And so normally we do x's and we get rid of the y's. And so that's what I'm going to do. I'm going to use 0, 0 as my origin because that's what it says right here. And then for my other point, I'm going to use x, but I'm not going to say y. I'm going to say 3x minus 2 because that's what they give us. They said that y is defined by x with the 3x by multiplying x by 3 and you subtract 2. And so now I can rewrite my distance formula with no y's. And this is what it looks like. But now let's clean it up a little bit. We have a distance formula written in terms of x. We're going to take the derivative of it. The square root is 1/2 power, and so that's why there's a 1/2 out in front. And then I got to simplify this. I got to go 3x minus 2 times 3x minus 2. And after I do that, I get 9x squared minus 12x plus 4. And then I have my minus 1/2. Okay, the chain rule says that after you take the derivative of the outside function, which in this case is the square root or the 1/2 power, then you take the derivative of the inside. So let's simplify the inside a little bit. We have 10x squared. And then we're going to take the derivative of that. We get 20x minus 12. Okay, a little more cleaning it up. The 20x minus 12 is going to go on top with the 1 right here. And then all of this stuff gets to go on the denominator because of the negative 1/2 exponent. And so I put that on the bottom with the square root instead of the 1/2 exponent with the 2. All right, we got our d prime. We have the derivative of the distance. Now we need to find our critical values. So I'm going to take the numerator and set it equal to 0. And when I do that and I solve it, I get 3/5. And then I had to find where the denominator equals 0 because I also have to find out where we are undefined, where we do not exist, where the slope does not exist. And so I set this equal to 0, divide both sides by 2, and then I try to factor. I realize factoring doesn't work, and then I have to use the quadratic formula, which is boo. Okay, so you have to refresh on that if you don't remember the quadratic formula. And then a little bit of simplification will show me that I get a negative 4 on the inside of the square root, which means that we would get an imaginary number, which means we get no critical value. There's no other critical value where the slope does not exist. Okay, so that means 3/5 is our only critical value. Now we're trying to find where we are the closest, which means we're looking for the minimum distance, a minimum. And so that means we want a negative positive. And so we got to figure that out by using tester points, or on a sine line graph. Or what we can do is we can do the second derivative test. And when we do the second derivative test, what you do is you find the second derivative of distance, and you're checking to see if 3/5 would give you a positive number. And that would tell you that you are concaving up, which guarantees us that right there we have a minimum value. But I don't really want to take the derivative of that, so I'm going to go do my sine line graph. So I'm going to plug in 0 and 1, and when I plug in 0, I plug in 0 right here, it's clear that we get a negative number on top. And then when I plug in 0 on the bottom, this will go away, this will go away. I have the 2 times the square root of 4, which would be a positive number. A negative divided by positive would be a negative, and so this checks out. And then I have to do the same thing with the 1. I plug in 1 up top, I'm going to get a positive number this time. I plug in 1 on the bottom, I'm going to get 10 minus 12, which is negative 2, but then I'm going to add 4, it's going to be a positive 2. So now we have a positive times a positive square root of 2, which means we have a positive divided by positive, which means the plus sign also checks out. That means this is the minimum value. This point works. This x value gives us the right one. And here's a official graph to help you guys see it. That is definitely the shortest distance from the origin to a point on the line. Now the calculus part, guys, isn't hard because all we're doing is we're finding critical values. Max or min. The hard part is the algebra. Algebra is hard here. You have to be able to write the distance formula as a function of x, and you have to remember the distance formula. So optimization is not a really hard concept. It's just the algebra to do it is really hard.